Now we get to have fun with designing the mechanics inside the mechanics box, the mechanical engineering box, what else could we call it? It would be this is a great research project. What do you call a housing in which the mechanicals are located? The name for the housing that holds mechanical systems depends on whether you are referring to an entire room or an individual protective casing. And in this case, it would be of course, the chassis. Yes, of course, the chassis, kind of like in a car. So this would be the mechanical chassis. Let us, in fact, call that the mechanical chassis. So we're going to go to our rough here, and we're going to open this up, and we're going to name this the chassis. Chassis. I'm trying to make it sound French and sexy, but it's not coming out that way at all. It's also very difficult to make a toilet mechanisms sexy. It is not a device that is usually associated with romance. Although that would be a really interesting romance novel, comedy, starring Matthew McConaughey and Jennifer Lopez. The toilet chassis. Let's turn off the rough and let's start building that chassis. Actually, let's turn that back on again. It's supposed to be about that big, but we'll see where it goes. What are the elements that we need to make sure that now remember, this is the hinge that will open and close the toilet. This is the wheel that will be used to turn this lever here. So that's this wheel here. What are the different parts of a pulley or what are the different parts of a pulley system? Not exactly what I was looking for. A pulley, parts of a pulley system, like on an elevator. All right, very good. So that's what we're looking for. What are the different parts? Yes, correct. All right. Counterweight. Oh, very good. Oh, we can use this concept. Oh yeah, right, very good. That makes even more sense then. Ultimately, we will need a counterweight, a second pulley. So the electrical motor turns. So ultimately, we need this to turn, that's to turn this, and then we need a... Now remember, this is not necessarily going to be accurate ever. These are never accurate. Overdone mechanicals is not supposed to be accurate so much as possibility. I like that word, huh? Possibility. There we go. There is our system. And in order to turn this piece here, this will all be inside the chassis. But I like to make the physical parts on the outside. It's much more steampunk and a lot more fun. You know, I always thought about, in Star Wars, for example, you have the Death Star, right? And on the Death Star, and I used to draw a picture like this when I was a kid, even before I ever saw Star Wars. On the Death Star, if you go close to the Death Star, you see all these like little things, right? You see all these little things that are there, you know, and then that makes up the, and of course you've got the windows, and then you've got the coffee shop, but you have all these things, and it, from far away, it looks like the rough surface of the moon. And you go close and it's got all those little things there. Well, that's also where Luke Skywalker had to fly through and then find the place where he was going to drop the bomb. Do you remember that? So you saw him flying through all the, you know, these different parts that's sticking out. Why would they be sticking out on a large planet, a artificial planet, when you could just keep it under the skin or the surface of the Death Star? Why would it be on the outside? What's the purpose of that? I never quite although it's kind of cool and kind of fascinating. Even the Millennium Falcon, right? The Millennium Falcon had, you know, had all the pieces sticking out, you know, all the pieces sticking out. And it's like, okay, you hit atmosphere, and then typically in any atmosphere that you hit going that fast, you're gonna burn up. Even if you're not hitting it that fast, you're still gonna burn up. Why would you keep all the peripherals on the outside, right? I mean, it doesn't make any sense. It would be like you get a Tesla and then it has all the wires on the outside of the car, like an exoskeleton. It's not gonna happen. But fun, it's always fun. So that's what I do with my overdone mechanicals. I keep everything on the outside. Some of the stuff is on the inside, and that's cool, but all right, so we've got this here, and then we also want to be able to, let's see, I'm gonna have a counterweight. The electric motor is going to drive this. Here's my electric motor, and we're gonna add some extra little things here that don't really have a purpose, but they could. Maybe these are capacitors. I love adding capacitors. I even love the word capacitor. In fact, if I had a pet dog, I might name that dog Capacitor. Cappy for short. Hey, Cappy. And the electrical motor should also probably have heat sinks. A heat sink, kind of like in motorcycles have an airflow heat sink, where you see the engines sitting out and you've got the gills. Those trap the wind as you're driving. The faster you go, the engine's gonna get hotter, but also cool down because the friction of the air hitting the gills, it traps that, and then it sucks it out, pulls it out because you're moving, and it takes the heat out. Also, because it's metal, having the gills kind of feed out, it lets the air flow through. And so in this case here, I would love to add some of those heat sink gills because it gets hot. It's gonna get hot. It's hydrogen power, man. Hydrogen power. In fact, I'm gonna ask the box, what do you call the heat sinks on a motorcycle? They are called cooling fins. That's right. I grew up in Japan, so often the words are different. So I now know that in America, because I had a motorcycle in America. Actually, the first vehicle I had, I never thought about it translating all those words, but the cooling fins, okay. So we're gonna have more cooling fins here. And remember that overdone mechanicals isn't always about the accuracy either. The fun part is making it look like it was hand-drawn, which it is, it's hand-drawn. It is not gonna be vector perfect, if you will. Okay, that is the electrical motor. And that drives this here. This is the electric motor belt, and it distributes the energy to this smaller wheel, and that distributes the energy to this much smaller wheel here, which opens and closes the toilet. So this electrical motor needs to be able to turn it left and right. So the left and right will be determined. Actually, no, because we discussed earlier that the closing of the seat and the seat cover is going to send energy back to the electric motor. Well, actually, two things that I didn't think about. One is we have a hinge for the seat, and we have to have a separate hinge for the seat cover. Unless you think that in your household or your friend's household or your parents-in-law household, that it's really up to the user to close the seat cover. I noticed that in some people's homes, they don't close the cover. I don't know why. It looks pretty disgusting, especially if the toilet is not completely clean. But then commercial toilets often don't have a cover, which I also don't understand, because the cover is what helps keep the bacteria and viruses from flying out when it flushes. That's why you should never look closely at a public toilet when you flush it, because it's going to end up in your face. And you don't want it to end up in your face. So let's keep it for now that it's only going to open and close the seat, not the seat cover. It's really up to the user to close the seat cover. I mean, it should be anyway. Mumbling. The electric motor is going to be given energy from, it's going to receive energy from the hydrogen-powered engine behind it, because it's going to generate electricity. But also the hydrogen engine needs electricity in order to power itself, right? Does it? Actually, let's check. Does a hydrogen-powered engine need electricity to run? And the answer is, it depends on the engine type. Hydrogen fuel cell vehicles use hydrogen to generate electricity, which powers an electric motor to move. Hydrogen internal combustion engines burn hydrogen like gasoline, but still require 12-volt battery and spark for plugs for ignition. So, all right, hydrogen fuel cell vehicles, which is probably what this is going to be, use hydrogen to generate electricity, which powers an electric motor to move. Okay, these engines do not run on combustion. Instead, they pass hydrogen through a fuel cell. Oh, you need an initial electric spark. Okay, great. So what we'll do is we will use the kinetic energy of the seat being lowered, because we'll just use gravity to lower. So it kind of jogs it ahead and it goes pew. As it's going pew, kind of like a hybrid engine like my car. It's kind of like a braking system. That is going to send electricity back to the hydrogen power engine, which will be behind here. Remember that's behind. That is our hydrogen engine, this will have to be triggered by a battery-powered ignition. Okay, so we're going to use that, and we're also going to use the centrifugal force of the water rushing around the toilet bowl as it flushes down into the bowl, into the tureen. So that's pretty cool. A reciprocal, friendly kind of relationship that these two will have. So here's our electric motor, which is powered by the hydrogen engine to turn this wheel here, which then in turn with a belt turns this wheel, which then turns this wheel. So really this is only needing to go in one direction, and that is raising the toilet seat cover. And then lowering is just a matter of a little blip, and then it goes down. So the power to lift it will be here. Of course, that's pretty large electric energy. Is it really going to require the fins? Probably not. These cooling fins, probably not. But it's funny because it's overdone mechanicals, Like if you asked me to make bacon, like my younger daughter used to complain that when I would make hamburgers or fish or any kind of meat, I would always overcook it. Now I always overcooked it because, you know, I'm trying to avoid any kind of bacteria that's gonna make anyone sick. Plus I love the crunchiness, but they didn't. They liked pretty much, our two daughters, undercooked hamburgers. Anyway, so do we need the heat sinks? The cooling fins? Let's keep them because it's funny. It is just funny. And does this wheel need to be that big? No, it doesn't. You know, the seat cover isn't that heavy unless it's made of gold. I really don't think that these seats are made of gold. If anything, they're plastic, and that requires less lifting and less power and less energy, and also it's not going to slam shut, although it needs to have some weight because that's going to help create that friction which generates electricity. So it's going to be solid plastic, not porcelain, although, no, that'd be too heavy for it to be lifted. So solid plastic, it is. Great. And because the hinge is near the back, the propensity for it to generate power is increased because, as we discussed earlier, the centrifugal force, or the outer rim, which would be the rim, like of a wheel, is far away enough that it creates that power dynamic. I don't even know if this is being realistic. Again, engineers, please tell me if I'm speaking out of my butt. I probably am, but I'm learning something here. You can't stop me from learning. All right, so we have this here. Okay, electric. Great. Now, what is it that the toilet seat closing needs to send back to the hydrogen? So we need to figure out where in this process is it going to redistribute the energy. Well, let's do some research. I'm going to ask, how does a hybrid engine in a car work? How does it send energy back to battery? All right. The way I ask questions, It is so basic. A hybrid engine seamlessly pairs an internal combustion engine with one or more electric motors which are powered by high voltage batteries. The car's brain automatically chooses. The car has a brain? The car has a brain? Do we need to call it a brain or just call it a computer? Probably just a computer. Probably just a computer. The car's brain automatically chooses, because if we're calling it a brain, that means that my iPhone is smarter than me. Regenerative braking. When you let off the gas or press the brakes, the electric motor runs in reverse. It acts as a generator, using the car's forward momentum, kinetic energy, to create electricity, which is then routed back into the hybrid battery. Right, so we've discussed that already. The combustion engine, when the car is cruising at steady speed or idling, the gas engine can spin an electric generator to put power directly back into the battery for later use. Perfect. So we need to figure out where the kinetic energy is going to be redistributed back to the battery. Let's look at a picture here of how that works. So how does a hybrid car work? We have the generator, gasoline engine, fuel tank. All right, we have that already. I just need to know how it sends the electric motor powers the car by drawing power from the battery. Priority is given to the electric motor, the gasoline engine, electric motor and the gasoline engines work together to power faster, slowing down. Since the vehicle is slowing down, the gasoline engine will stop working, just rely on the electric motor. The generator recovered the power produced by the spinning wheels and stores it in the battery for later use. Well, this is turning, and this is also turning. So the thing that's moving more quickly is this one here. Because it's smaller. Remember how we mentioned earlier with a bicycle, the distribution of speed of the gears and the kinetic energy you need to move the bicycle forward more quickly. When the front is the larger gear, sorry, I'm way off over here. If the front is the larger gear and the back is the smaller gear, ultimately you can go faster because the speed at which this is moving moves this even more quickly. And if you're already going at a certain speed, it's easier to propel yourself forward. If the front is small and the back is big, you're turning very quickly here and slower here, which is great for going uphill. And it's easier to go uphill when you redistribute this, the kinetic energy that way. So in order to send back enough energy back to the hydrogen engine to ignite it, to get it started, the redistribution of energy should be at the smallest wheel or hinge or gear, which is down here. So what would be really cool is to have an even smaller wheel here. This one is attached, oh, it can't be on the edge there. Well, it actually could be. Actually, yes. This could keep the belt tight. So this has two purposes. The purpose is to keep the, and I'll color these in so you can see them, is to keep the fan belt, keep the belt tight and also redistribute the energy. So we're actually going to go back to our wheel here, our belt, and we're going to erase the belt. Actually, add a little wheel here. And I forget what this is called, and we'll do some research. And this tightens it. It also is going to be used to redistribute the energy back. So what do you call the small wheel that tightens fan belt? Belt stretcher, belt tensioner, the tensioner pulley, idler pulley, replacement, tensioner pulley. So this is the tensioner pulley, and also it redistributes some electricity toward the hydrogen power. So this will be connected to some kind of energy collector, and let's make that more interesting and more fun. This is this is on a spring system. So I'm going to add this on a spring system, and this keeps it tight, and this turns and redistributes Okay, great. Let's have a secondary. This keeps it in between. Now this one here, this top one, this turns and collects that power inside a, what do you call it? What do you call the little device that collects energy and converts to electrical power? It's a of course. This is a transducer. Great. So the transducer will send a spark of energy. Transducer. And it sends it back. So we'll just place that there. This is our transducer. So what we figured out here is the kinetic energy, the electrical engine, small electrical engine, capacitors, wheel, belt, and then the turning of the speed and the turning of the seat being lowered will just generate just enough electricity that will be fed out this way to the hydrogen-powered engine. Great. So we have that. We understand now also that this is a chassis. So this will be inside the chassis, or rather they'll be sticking outside of the chassis. You'll see it, but it'll be there. Cool. All right. Well, we've gotten somewhere. Excellent. See you next time.